Okay, in this video I'm going to begin section 3.4, which is called the chain rule. I feel like the chain rule is one of the most important things that we'll be talking about so far. The reason why I say that is because the chain rule is going to come up a lot all throughout the rest of the book, okay? It kind of ties in the other stuff that we've talked about also, so let me get right to it here. It says that if y is a function of u, and that's a differentiable function, and u is equal to g of x, and that's a differentiable function of x, then y equals f of g of x is a differentiable function of x, and the derivative of y with respect to x would be the derivative of y with respect to u times the derivative of u with respect to x, or equivalently, if you differentiate f of g of x, you're going to take f prime of g of x and then multiply by the derivative of g of x. Okay, I've got a partial proof here. You guys can look at that on your own. I'm more concerned that you can use the chain rule correctly. It is so important. We'll be using it a lot. And here's the proof if you want to look it over, okay? Like I said, it's a partial proof. A complete proof is given at the end of the section in the book. So let's take a look at some examples here. Now, the idea with the chain rule is to identify an inner function and an outer function. And when you differentiate, you're going to first identify what rule you're going to be using, but then you're going to leave the inner function alone, and you're going to apply the appropriate differentiation method, and then you're going to multiply by the derivative of the thing that you were ignoring at the end, okay, in order to finish the chain rule. So here's an example. Suppose that I want to differentiate f of x equals 7 plus 3x minus 2x cubed, all that to the fifth. Okay, well this would be an ideal chain rule situation, okay? 7 plus 3x minus 2x cubed is inside of x to the fifth. So I'm going to begin the calculation as if it were just x to the fifth. I don't have x to the fifth, but that's how I'm going to start. I know that I'm going to bring down the power of 5, reduce the power by 1. Now, 7 plus 3x minus 2x cubed, that's the thing that I'm temporarily ignoring here. And I'm going to multiply by its derivative in order to finish the chain rule. The derivative of 7 plus 3x minus 2x cubed is 3 minus 6x squared. So here'd be my answer then. Now, this would be an ideal chain rule situation because I wouldn't want to consider simplifying something like this, okay? If I were to simplify, that would be a lot of algebra, and I would have a degree 15 polynomial that I would have to differentiate all the terms and then try to write something in a simplified factored form. That sounds very brutal, okay? So, the chain rule is here to make life easier than what it could have been, okay? Now, sometimes our only option is to use the chain rule. So, like, here's another example. Suppose that I have g of x equal to the square root of x squared plus 1. My only option for finding the derivative is to use the chain rule on something like this. Now, x squared plus 1 is inside of the square root function. So I'm going to begin the calculation as if it were just the square root of x. I don't have just the square root of x, but that's how I'm going to begin the problem. Okay, now the square root of x, that's the same as x to the 1/2, right? And so I'm going to bring down the power of 1/2, reduce the power by 1. X squared plus 1 is inside the square root function. That's the thing that I'm ignoring temporarily. And so I have to multiply by its derivative in order to finish the chain rule. The derivative of x squared plus 1 is 2x. And now simplify, the 2's cancel there. X squared plus 1 to the negative 1/2 power, that's the same as 1 over x squared plus 1 to the 1/2 power, or using radical form, my answer would be x over the square root of x squared plus 1. Again, make sure that you're simplifying as far as possible with all these problems here. Okay. Now, probably the mistake that I will see students make the most in the chain rule is that they won't finish the chain rule. Like they'll forget to multiply by the derivative of the thing that they're ignoring here in order to begin the chain rule. Don't do that. Okay, make sure that you finish using the chain rule there. Otherwise, the answer is not correct. Okay, here's another example. Y equal 1 divided by 2x to the 5th minus 7 cubed. Well, let's see here. So there's a couple of different options that I could use here in a problem like this. I could use the quotient rule. Now, if I were to use the quotient rule, I would need a chain rule inside of the quotient rule. So maybe to avoid that, why don't we look at 1 divided by 2x to the 5th minus 7, all that cubed. That's the same as 2x to the 5th minus 7 to the negative 3rd power. Okay, and I can just treat this as just a chain rule problem then. The derivative of y with respect to x, or dy dx, would be using the chain rule, like I said. Now I'm going to begin as if this were just x to the negative 3rd. Okay, so bring down the power of negative 3, reduce the power by 1. 2x to the 5th minus 7, that's the thing that I'm ignoring here. So I got to finish the chain rule. I got to multiply by the derivative of that. The derivative of 2x to the 5th minus 7 is 10x to the 4th. Okay, simplify. Also, like what we were doing before, give your answer without negative exponents. Okay, that's how the book will want it. So we're going to have negative 30x to the 4th in the numerator divided by 2x to the 5th minus 7, all that to the 4th in the denominator. Okay, here's another one. Y equals sine of x squared. Well, x squared is inside of the sine function. So this would be a chain rule situation. I'm going to begin as if I were differentiating just sine x. I know the derivative of sine x is cosine x, right? Now I don't have just sine x. I got sine of x squared. So I'm going to leave the x squared alone, and I'm going to start by writing cosine of x squared, but then I got to finish the chain rule. I got to multiply by the derivative of x squared is 2x. So 2x times cosine of x squared, that would be my answer. Now what if I had written it as y equal sine squared to x? Well, these two are different, right? X squared is inside of the sine function on this first problem. Sine x is inside of the square function on this problem. So in this problem, I'm going to begin computing the derivative as if it were just x squared. I'm going to bring the power down. I'm going to leave the sine x as is, but then I got to finish the chain rule. I got to multiply by the derivative of sine x, which is cosine x. Okay. Another thing that I will see students struggle with is identifying what's the inner function and what's the outer function. Try to get some practice with that. Okay, think about which function is plugged into the other one, because that's really what we're working with here, right? We're working with function composition. G of x is plugged into f of x. Here's another example. Y equal cosine of tangent x. Okay, well, tangent x is inside the cosine function. And by the way, I don't have a product, right? Some students will mess this up and they'll want to use product rule. Don't do that. I don't have cosine x times tangent x, right? I have cosine of tangent x. Tangent x is inside the cosine function, so I'm going to begin as if it were just cosine x. The derivative of cosine x is negative sine x. So I'm going to begin by writing negative sine of tangent x, but then I got to multiply by the derivative of tangent x, which is secant squared x. Okay. Let's go to this page here. So sometimes when you're using the chain rule, some other rules for differentiation are going to be mixed in. Okay. So in this problem here, I have 3t minus 1 over t squared plus 3 is inside of t to the 7th. Okay, so I'm going to begin as if it were just t to the 7th, okay, using a power rule. Bring down the power, reduce the power by 1, but then I got to multiply by the derivative of the thing that I'm ignoring here, and that's going to be a quotient rule situation. So when I apply the quotient rule, the bottom is t squared plus 3 times the derivative of the top, that'd be 3, minus the top, that's 3t minus 1, times the derivative of the bottom, that's 2t, all over the denominator squared. Simplify that. Okay, so let's see, if I distribute 3, I'm going to have 3t squared plus 9, and then it's going to be minus 6t plus 2t. I'm also splitting this part here into two expressions, 3t minus 1 to the 6th divided by t squared plus 3 to the 6th. The reason why I did that is because in the denominator I can combine these. I'm going to keep the base and add the powers. So I get t squared plus 3 to the 8th. And that would be as simplified as I can get it. Okay. So yeah, it'll sometimes happen where maybe you've got a chain rule, but inside of that you got a quotient rule, or maybe you got a product rule, and inside of that you got a chain rule. Okay, or maybe you got a chain rule, and inside of that you got another chain rule. So I like this section in that. For several reasons. Number one, we're going to have to know it anyway because it's, all over the place. But number two, it's a good recap of the things that we've already talked about with like power rule, product rule, quotient rule, the trig stuff, So let's take a look at, here's another example. F of t is a product. And so to begin, I'd want to use the product rule. Now, one thing that I would say, to consider when you're starting these problems, think about which rule you're going to be using, okay? I sometimes have students that have a tough time getting started with the problems because they can't identify, is this a product rule or is it a chain rule, or, have a plan with how to start the problem at least, okay? I've got a product, I know right away I'm going to use the product rule. Well, let's use that. So I've got the first times the derivative of the second. The derivative of the second is going to be a chain rule. The cubed root of 9t plus 2, that'd be the same as 9t plus 2 to the 1/3 power. The power of 1/3 can come in front. You're going to leave the 9t plus 2 alone. Reduce the power by 1. 1/3 minus 1 is negative 2/3. But then finish the chain rule. You're going to multiply by the derivative of 9t plus 2, that's 9. Okay, so back to the product rule. I said first times the derivative of the second plus the second times the derivative of the first. The derivative of the first, that's me another chain rule. So you're going to bring the 3 down, reduce the power by 1, and then 1 minus 4t, that's inside of the cube function. I'm leaving that alone as is. And then, but I got to finish the chain rule, right? I got to multiply by the derivative of 1 minus 4t, which is negative 4. Okay, and then simplify that. So 1/3 times 9 is 3. 9t plus 2 to the negative 2/3, that's the same as 1 over 9t plus 2 to the positive 2/3. Okay, minus, remember this, 3 times 4 is 12. And I've left everything else as you see it there. Okay, and here'd be the answer to that. Okay, here's another example. Y equals e to the sine theta times cosine theta. Well, that's another product rule situation, right? So let's start with the product rule. We're going to have the first is e to the sine theta times the derivative of the second. Derivative of cosine theta is negative sine theta. Plus the second, that's cosine theta, times the derivative of the first. Okay, the derivative of the first, that'd be a chain rule. I know the derivative of e to the x is itself e to the x. Now I don't have e to the x. I've got e to the sine theta. Since sine theta is being plugged into the function e to the x, I'm going to leave that term as is. And so the derivative of e to the sine theta would be e to the sine theta, but then times the derivative of sine theta, that's the thing that I was ignoring. Derivative of sine theta is cosine theta. E to the sine theta is in common to these two groups. You can factor that out. And I'd have cosine squared theta minus sine squared theta then is the, minus sine theta, excuse me, is the leftover. Okay, here's another one. Y equals secant of 3x squared minus secant of 3 times x squared. Well, secant of 3x squared, that'd be a chain rule. 3x squared is inside of the secant function. So I'm going to begin as if it were just secant x. The derivative of secant x is secant x tangent x. So I'm going to start by writing secant of 3x squared times tangent of 3x squared, but then times the derivative of 3x squared. That's 6x. Now with this term, secant of 3 is just a number. So I know constants can come out of derivatives. Derivative of x squared is 2x. And let's see here. So I guess I've just pulled the 6x to the front there. And you can pull the 2x to the front so that it doesn't look like 2x is inside of the secant function, right? It's not. 3 is inside, but that's it. Okay. And here's another example. Y is equal to the square root of x plus the square root of x plus the square root of x. Okay, all that inside each other. Well, that's the same as x plus the quantity x plus 1/2, x to the 1/2 to the 1/2 power, all that to the 1/2 power. Okay, and this is how I'd want to think of it because I'm going to use the chain rule twice in this problem. I'll be using the chain rule. And so let's start as if it were just x to the 1/2. Well, the derivative of x to the 1/2, that'd be 1/2 x to the negative 1/2. And I don't have x, right? This part is what I'm temporarily ignoring. So I got to multiply by its derivative, right? I got to finish the chain rule here. The derivative of x is 1. The derivative of x plus x to the 1/2 to the 1/2 power, that's going to be another chain rule. So I'm going to bring down the power, ignore the inside here, x plus x to the 1/2, reduce the power by 1, but then I got to finish the chain rule. I got to multiply by the derivative of this thing that I'm ignoring, x plus x to the 1/2. Well, that's 1 plus 1/2 x to the negative 1/2. And I've rewritten this now in radical form to give the answer. Okay. So yeah, that's what I was saying before. Sometimes you might have one rule within another rule. Like in this problem, we are using a chain rule within a chain rule. That'll sometimes happen. Now, in section 3.1, we had looked at kind of an investigation of the derivative of f of x equal a to the x. I had my notes here from earlier. We can actually create a general formula for the derivative of a to the x now. It's a to the x times the ln of a. To prove that, we'll need to use the chain rule along with some things about logarithms. A to the x, that's the same as e to the ln of a to the x. And I'd want to write it in that form because then I can use the chain rule. The derivative of e to a power is always going to be e to the power times the derivative of the power. Okay? The derivative of e to the sine x is e to the sine x times the derivative of the power is cosine x. All right, so derivative of e to a power is e to the power times the derivative of the power. Derivative of ln a to the x, well, I know exponents can come out of logarithms, right? So I've got x ln a. Ln a is just a number. So the derivative of x ln a, that'd be ln a. And that's where the formula comes from then. The derivative of a to the x is a to the x times the ln of a. Now, how about what if we want to find the derivative of y equal 2 to the x? Dy dx is 2 to the x times the ln of 2. Right? A to the x times the ln of a is the general formula that gets you the derivative. Now this should look familiar, okay, because we had done a little bit of this in section 3.1. The derivative with respect to x of 2 to the x was roughly 0.69 times 2 to the x. Now we were using a table and kind of guessing the value of a limit here in setting this up, but the 0.69 is actually an estimate of the ln of 2. Okay, so the exact answer would be 2 to the x ln 2. Here's one more example. How about y equal 10 to the power 1 minus x squared? Okay, that's me a chain rule. Well, the derivative of 10 to the x would be 10 to the x times ln 10. Now I don't have 10 to the x, right? 1 minus x squared is inside of that function. So I'm going to ignore that exponent and just begin as if it were just differentiating 10 to the x. Okay, so I'm going to have 10 to the 1 minus x squared times the ln of 10, but then times the derivative of the power. Derivative of 1 minus x squared is negative 2x. You can bring the negative 2x times ln 10 to the front, and that's the only thing that I did there to simplify. Here's my answer. Okay, the chain rule, I cannot emphasize enough how important that's going to be. Be sure that you get the practice working with the with the problems in this section. We're going to be doing lots and lots of things with the chain rule as we dig deeper into calculus. So the homework is on page 204. Be sure to look at the odd numbered problems there for me.